Good morning, guys. Welcome to the videos of Waec tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please go ahead and press the subscribe button and the bell. That's an update on this YouTube channel. Thank you and God bless you. Today we're going to be considering what 2022 Waec GCE Chemistry Practical. 2022 Waec GCE what Chemistry what Practical. And today we're going to be considering the first questions in the practical, which is known as volumetric analysis. Know fully well that this exam we are going to be tested based on alternative to practical. This is going to be what an experiment that has been done before, which you are given to just analyze based on the what information given to you, and that's what we are going to do as far as what all the practicals in GCE is concerned. And this is an example of one of the ways they can set the questions and under the volumetric analysis. Now we are told that in an experiment 20 centimeter cube portion of 0.065 mol per dmK sodium hydroxide were titrated against dilute HCl. The table below shows the results of the titration. Now, an experiment has been carried out, and we are told that 25 centimeter cube portion of sodium hydroxide were titrated against dilute HCl. The table below shows the result of the titration. Now, this is the table of titration. We are seeing the grade reading, the first titer, the second titer, and the third titer. We have the final reading, the initial reading, and the volume of acid used. Name the suitable indicator for the titration. Give a reason for your answer. Now, the first question is to identify which one is your acid and which one is your base. Now, because the type of acid and the type of base used will determine the kind of indicator that I use for the reaction. Now, we are given that a portion of 0.65 mol per dmK of sodium hydroxide were titrated with dilute HCl. Now, meaning that we are having titration between sodium hydroxide. Let's have the acid first, which is HCl. Plus HCl plus sodium hydroxide. Now, sodium hydroxide is a strong base. This is a strong This is a strong base. This is a strong base. And HCl is is a strong acid as well. This is a strong acid. Now, based on the fact that this is a strong acid and this is a strong base. Now, any indicator is suitable. That is, whenever you are having a strong acid and base, any indicator is suitable. Whichever indicator that you mentioned here, any indicator is suitable, but you have to specify this time around. Any indicator is suitable. Any indicator is suitable. Now, but we have to mention a suitable indicator. Now, you have to mention that indicator. If you rank any indicator is suitable, then you are going to lose mark for that. So that's why you have to mention we have different type of indicators. You can mention one of it is we are talking about. You can mention one of these indicators. You can mention melty orange. Melty orange. This is the first indicator we can use. Is melty orange. You can also use phenolphthalein. Phenolphthalein. You can also make use of You can also make use of methyl red. You can also use of methyl red or methyl red. So which all of these indicator can be used because it's a reaction between strong acid and strong base. So that's the first answer to the question. Let's give the reason why this indicator can be used. Now, the reason why the indicator can be used is whatever answer you decide to write here, that is whatever indicator you decide to write here, this should give reason for giving that indicator. The reason is that this is a reaction or this is a titration between strong acid and strong base. So the reason why you suggest these indicators now is that it is a titration. It's a titration between titration between what? The titration between acid, between strong acid and strong base. And strong what? Base. It's the titration between strong acid and what? And strong base. So that's that about that. So the next one is what? Is to answer the A Roman figure 1. This is A Roman figure 1. This A Roman figure 2 now. A Roman figure what? 2. So now, what is the question in A Roman figure 2? Give the color of the indicator in the base and at the end points. Now, you have to give the color of the indicator of this indicator at what? At the base and at the end points. Now, I'm going to be giving two of these indicators. Like if I choose the first two, which is methyl orange. Now, the indicator now, we have indicator, the color in base, because since you have tell us the color in base and at the end points, color in what? Color in the base. Then color at what? At the end points. Color at the end points. Color at the end points. So now let's check now. Now if I'm using what? Methyl orange. Now if I'm using what? Methyl orange, which is the first indicator here. Methyl orange. If you are using methyl orange, what will be the color? The first one, if I am using the methyl orange, what will be the color in base? Color in the base will what? Will be yellow. It will be yellow. So there's no doubt about that. Now it will be yellow. And at the end point, it will be orange. So when you use phenolphthalein. Now the color in base will be pink. Why the color here will be what? Colorless. So the color of what? Of methyl red also will follow this yellow and it will follow what? It follow yellow and orange. But majorly the methyl orange and which is the what? Which is the most common what indicator used for the titration. Now the methyl orange will be what? Yellow in what? It will be yellow in base. While it will be what? At endpoint it will be orange. It will be what? Pink in what? In base, and at endpoint it will be what? It will be colorless. So that's that about what? Roman figure 2. Now let's go to what? B Roman figure 1 now. We are not asked B Roman figure 1. What is the question here in B Roman figure 1? We are asked to write a balanced equation for the reaction. Write a balanced equation for the what? Reaction. Now what is the reaction now? Is the reaction between sodium hydroxide and HCl. We are going to write a balanced equation for this HCl and sodium hydroxide. So how do you write that? HCl plus sodium hydroxide to give sodium chloride plus. Now, this is a reaction between acid and base. Definitely, you are going to have salts. So, the reaction this is an acid. This is the base. The first product we are going to have here is what? Is the salt. And this is a reaction between what? Strong acid and strong base. Then you are going to have water again. So it's a reaction between what? Strong base and strong acid to give what? Salt and water, which is also known as what? Neutralization reaction. Now, with this now, determine the what? We have to write what? The reaction. You can see it is balanced. We have one hydrogen here. One hydrogen. We have what? So now look at it very well. How many hydrogen are we having here? One hydrogen here plus this one making 2. We have 2 already. We have one sodium here, one sodium. We have one O, one O. So it's balanced. So you must ensure that your equation is balanced whenever you are doing your exams. Now, if they ask you to balance any equation, now determine the average volume of acid use. You are asked to determine the average volume of acid use. That's Roman B Roman 2. Determine the volume or the average volume of an acid use. Now, to determine the average volume of acid use, you have to go back to the table. And let's go back to the table now to determine what. Here we are going to be what? You are going to need calculator. Let me take one my calculator. Now, Here now, we have to calculate what? Determine the value of the average volume of acid use. So I determine the what? The average volume of acid use. Now, going back to the table now, we are given what? The Burette reading in centimeter cube, the first title, the second title, the third title. The first thing is to calculate the volume of acid used first. Then from that you can obtain your average volume of acid. Now the final here minus the what initial. Now here with 23.50. Now minus 0. Now 3.50 minus 0 will be 23.50. So 46 minus 23.50. So we have what? 23.1 here, 10 here. So then the last one here, which is what? 47.40 minus what? 24 point. Now this is 24.400. This is for 24.00. So this one will be what? 24. So this one is 23.40. Now to 2 decimal places. Be mindful of that. The calculator is leaving it towards 1 decimal place. You are to leave it to 2 decimal places because you are given what? You are given this data in 2 decimal places. So don't leave your own in 1 decimal place. So please be mindful of the what? The place value you are using for what? Or the rounding up for what? For the data given to you. So if it's 2 decimal places that they give to you, leave your answer in 2 decimal places. So that's that about that. So now having what? Gotten the volume of acid use in each title. Now the next thing is to consider which of these title is concordant. Is everything concordant? Can I use everything? Now let's look at it very well. Now this is 23.50, this is 23.10, this is 23.40. Now you can see that this 23.10, the difference is 0.3, and this one is 0.4 here. So now, but this and this are just difference of what? 0.1. When you remove 23.40 from 23.50, you have 0.1. So the concordant value should be between the range of 0.1 to 0.20. Concordant values. Concordant what? Concordant values. We call it concordant values. Differ from one another with what? Differs from one another. Differ from one another or each other. If there are 2, one another differs from one another with range of 0.1 to 0.2 centimeter cube. So that's the difference. So it must not be what? The difference must not exceed 0.2. So you have to be mindful of what? The difference. So now this one difference here is 0.1 centimeter cube. So this is the 2 concordant values because they are the one that will obey the range of what? 0.1 to what? To 0.2. So the concordant values differ from one another with 0.1 to 0.2. So which means that this first title value, which is what? The first title value here, which is 23.5, and the 2 concordant values. So these are the things, these are the title values that I want you to calculate our average volume of what? Acid use. So the average volume of acid use now, is going to be the what? The first title. The first title value plus the what? The third title divided by 2. Divided by 2. So we have what? We have 23.50 plus 23.40 centimeter cube divided by what? 2. So we have what? We have We have what? 20 what? 23.50 plus 23.40 divided by 2. So you have 23.45 centimeter cube. So that's that about that. Now, so we have successfully calculated what? The value of what? Roman figure what? 2. That is determine the value average volume of what? Acid used. So that's that about Roman figure what? Roman figure 2b. Now, calculate the concentration of the acid in mole per dmq. We have to calculate the concentration of the acid in mole per dmq. That's what? C. Calculate the concentration of the acid in mole per dmq. Concentration of the acid in mole per dmq. In mole per dmq. Concentration of acid in mole per dmq. Now, how do you go about concentration of acid in mole per dmq? The first thing is to identify your acid, which is the what? HCl. So you have to calculate the concentration of acid in mole per dmq. Now look at this. There is nothing given to us about what? The acid, except the average volume of acid what? Used, which is what? The VA. So the average volume of an acid used is what? VA, which is the only parameter given to us for A. Now, and we have to calculate the concentration of what? Of A in mole per dmq, which is Ca. The concentration of A in mole per dmq is a type of concentration of what? Of X substances in mole per dmq is what we call molar concentration, and it is concentration of the substance in mole per dmq. There's another type of concentration which is concentration in gram per dmq, which you call mass concentration. So for this time around, we are asked to calculate the concentration in mole per dmq, which is a molar concentration, that is mole per volume. Now, another thing that we are given about A is the mole ratio. Now look at this. We have this is A and this is B. The number behind this was this formula here. This chemical formula is 1. So we can say that our Na here, our Na, which is the number here, is 1, and our Mb here is also what? It's also 1. So another thing we are given here is the number of moles of acid in the chemical reaction. So Na is what? Is 1. So with this now, and what are we given from B that can help us calculate what? The concentration of acid what used is that we are given the molar concentration of sodium hydroxide. Note the what I'm saying, the molar concentration, that the concentration in mole per dmq. As you can see that 0.065 is the mole per dmq. Mole per dmq. So that is molar concentration. So we have what? The Cb is what? 0.065 mole per dmq. Mole per dm cube. It's very, very essential. Don't forget that this VA has been given to us. It's not unknown. Sorry for that. The VA is not unknown. The VA is 20 what? What do you get? 23.45 centimeters. So 23.45 centimeter cube. So please note that 23.45 centimeter cube. Now the CB is 0.065 mole per dmq. And what about the VB? The VB has been given for us from the question 20 centimeter cube. Please note that 20 centimeter cube. Don't use what you are not given. As far as this thing is concerned, don't use it, because if you use it, if you think okay, the volume of pipette is 25, usually the usual pipette that we usually use is 25, and you decide to use 25, you're going to what? Lose mark for it. Now, this is the volume used to pipette. This is 20 centimeter cube, because there are two types of pipettes: 25 centimeter cube pipette and 20 centimeter cube pipette. And here we are given what? 20. So the VB here, which is the volume of the pipette, is what? 20 centimeter cube. So that's that about that. So with these parameters now, and the last one is NB. NB is also 1. With these parameters now, you can now calculate your known, which is your CA here, CA, the CA, which is molar concentration here. So now, how do you go about that? Using what? Using CA VA over CB VB equal to NA over what? NB. So with that, now we can substitute the parameter. Your CA. CA is what we are looking for. CA times VA, 23.45 over, and your CB is 0.065 multiplied by your what? Your VB, which is 20, equal to 1 over 1. So do what to cross multiply. 1 times this one, it remains like that. So we have CA times 23.45. And this one is 0.065 times 20 divided by 23.45. 23.45. So this one cancel out this. We have CA is equal to what? So now let's press the calculator here. You have open bracket. Now you can easily press it once and for all. 0 open bracket 0. What? You open the bracket here. Open the bracket here, then you close it. So we have what? 0.065 multiplied by 20 bracket close divided by 23.45. So we have 0.065 times 0. So 0.065 times 20 divided by 2 is what? 0.055 dm cube. You can form four sides to 4 decimal place first. Then mole per dm cube, because it's the concentration. So approximately 0.055 mole per dm cube. So that's that about that. Now we are asked to calculate what? The mass concentration of the what? The concentration of acid in mole per dm, which is mass concentration. The concentration of the acid in gram per dm, which is mass con, which I'm telling you the last time, is the what? Is mass con. That one is mass con. So now to calculate the mass con, let's quickly what? Clean the square of the what? Or now I'm done with this. Now I can easily what? Clean this. So now, here we are now, we are asked to calculate number 2, the concentration of acid in gram per dm cube. Concentration, that is B Roman equal 2, that is C Roman equal 2. Concentration of what? Of acid in gram per dm what? Cube. In gram per dm cube. Now, how do you go about the concentration of what? Of acid in gram per dm cube. I thought that the concentration of acid in gram per dm cube would what? Mass conc. Don't forget, this is also considered as mass concentration of acid, which is the what? The HCl. Now, mass concentration of acid now, which is HCl, will not be what? In other words, molar concentration equal to molar. That is, you calculate the mass conc of acid now. That is molar. That be equal to molar concentration of the acid itself multiplied by the molar mass of acid, which is what? HCl. Don't forget that the acid is HCl. HCl. So this one is HCl. So with that now, how do you go about it? With that. Now, the first thing is that, do we know the molar conc itself? Is the molar conc. We just calculate the molar conc. Now, what about the molar mass? Then we need to get the molar mass because we don't have the molar mass yet. So we have to get the molar mass of what? The molar mass of HCl, which is the acid. Molar mass of acid into brackets what? HCl. So this one is now going to be what? 1 plus 35.5 1 plus 35.5. So now, how do I get that? H is 1 from what? Give me here. H is 1. Chlorine is what? 35.5. So 1 plus 35.5 will give what? 36.5 gram per mole. Please know that molar mass is in gram per mole. So now with that now, you can also say mass conc now of acid now. Mass conc of acid. The mass conc of acid, which is what? HCl is equal to what? The molar conc now, which is 0.0554 multiplied by 36.5. So 0.0554 multiplied by 36.50. So this one will give you what? Give us 2.0221 gram per dm³. Gram per what? dm³. So with that now we can quickly what? Now use this one to calculate the last one, which says the mass concentration, the mass of HCl. The last question says the mass of HCl in 20 centimeter cube of solution. The mass of HCl, that is equivalent to what? 3. Mass of HCl in 20 centimeter cube of solution. Now, this is very simple. Now, look at this. If what this one means is that 2.021 gram per dm³ is dissolved in 1000 m³. This is what this one means. It means that what? 2.0221 gram of what? Of HCl was dissolved. Was dissolved in what? In 1000 centimeter what? Cube. That's what it means. Now, how many HCl now? How many gram of HCl will be dissolved in 20 centimeter cube of solution? So how do you now get that? You just say this one is X gram now of HCl now dissolved in 25 centimeter cube of water. In 25 centimeter cube of water. So now you have to cross multiply. When you cross multiply this with what? This. What do you have? X times 1000, that is 1000x. X times 1 is 1000x equals what? 25 times what? 2.2. I'm not using approximate value here, so I'm using everything. When you cross multiply, you have 1000x and this one times this. It's not even 25, it is 20. So 2.0021 gram dissolved in this, and X gram dissolved in 20 centimeter cube of what? Solution. So don't forget solution dissolved in what? 25 centimeter cube of what? 20 centimeter cube of solution. So if this is dissolved in 1000 centimeter cube of solution, and S of HCl will now dissolve in 20 centimeter cube of what? Solution. So by cross multiplication, this one multiplied by this, that's 1000x, and this one multiplied by this. So what do we get? So you multiply this together, but we can easily simplify our issue in one step. So divide both sides by 1000. So this one cancels out. So x will now be 0.0505 gram. So approximately to what? To 3 this one is 0.051 gram of HCl will dissolve in the solution of 20 centimeter cube of water, which is the solution. So that's that about that. Let me quickly clean this so as not to miss it up. So we have come to the what? So as I've said now that in this situation you said you have to compare this now. This gram of this was dissolved in this. So X gram will dissolve in 20 centimeter cube. So by cross multiply, you have 1000 is equal to this, and then you divide both sides to get what? Your final answer. So approximately now, 0.051 gram of HCl was dissolved in 20 centimeter cube of solution. 0.0 gram of HCl was dissolved. We dissolved in 20 centimeter cube of HCl of solution, not of HCl this time around, of solution. So 0.051 gram of HCl will dissolve in 20 centimeter cube of what? Of solution. So thank you for watching us today. Please, if you haven't subscribed, please do that to press subscribe button and click on the bell. That's our update on this YouTube channel. Thank you for watching us once again. See you next time. God bless you.